Good morning, everybody. Today we shall continue the chapter Acids, Bases, and Salts. In previous class, we shall discuss about the what are acids, physical properties of acids, what are bases, physical properties of bases, different types of indicators, chemical properties of acids and bases, how do metal carbonates and metal hydrogen carbonates reacts with acids. Okay dear students, today we shall discuss about how do acids and bases reacts with each other. Here, the reaction between a acid and base to give salt and water is known as neutralization reaction. Very important question in your examination. Here, what is neutralization reaction? Give an example. Here question is arise. What is neutralization reaction and give an example. Here the neutralization reactions means the reactions between acid and base to give salt and water is known as neutralization reaction. For example, sodium hydroxide reacts with hydrochloric acid, sodium chloride and water is formed. Here, sodium hydroxide NaOH reacts with hydrochloric acid. Here, NaOH is one of the base and HCl is acid. When base reacts with acid to give sodium chloride, salt and water is separated. So, reaction with metallic oxides. So in this reaction, metallic oxides reacts with acids to give salt and water. So metallic acids are said to be basic oxides. Metallic oxides are said to be basic oxides. And reaction of non-metallic oxides with base. Reaction of non-metallic oxides with base. So in this reaction, non-metallic oxides reacts with base to give salt and water. Non-metallic oxides reacts with base to give salt and water. And then non-metallic oxides are said to be acidic oxides. Non-metallic oxides are said to be metallic oxides. Are said to be acidic oxides. And then, what do all acid and all bases have common? All acids and all bases have common. What happen an acid or base in a water solution? So let us see through the activity. Here, take 2 iron nails are fitted on a cork and kept in a 100 ml beaker. Take 2 iron nails and fitted on a cork and kept in a 100 ml beaker. The nails are connected to 2 terminals of 6-volt battery through a bulb and switch. The nails are connected to the 2 terminals of 6-volt battery through a bulb and switch. Some dilute hydrochloric acid is poured in the beaker and switch on the current. So the same experiment is performed with glucose solution and alcohol solution. So what you have to observe? So if you observe that the bulb glows in the hydrochloric solution does not glow in the glucose solution. We observe that the bulb glows in the hydrochloric solution does not glow in the glucose solution. Because hydrochloric acid dissociates into H plus and Cl minus ions. Hydrochloric acid dissociates into H plus ions and OH minus ions. So these ions conduct the electricity in the solution and resulting in the glowing of the bulb. On the other hand, the glucose solution does not dissociates into ions. So therefore, it does not conduct electricity. So what we have to conclude at that? From this activity, it can be concluded that all acids contain hydrogen ions or H plus ions. So that is why through alcohol and glucose contain hydrogen, they are not categorized as acid. They are not categorized as acid. So acid reacts with water to give hydronium ions or H plus ions in water. But base reacts with water to give hydroxide ions or OH minus ions. Bases are soluble in water, so it is called it as alkalis. The reaction with acid or base with water is highly, so it is called it as exothermic. Heat generated may cause the mixture to splash out and cause burns. The glass container may also break due to excessive heat. So here acid reacts with water to give the hydronium ions or H plus ions. When hydrochloric acid dissolved in water, acids donate hydrogen ions or H plus ions. So hydrogen ion cannot exist in the absence of water. Hydrogen ion, note down the point here dear students, note down the point here, hydrogen ion cannot exist in the absence of water, but they exist after combining with water molecules. So thus hydrogen ions always be shown as hydronium ions or H3O plus ions. We have seen that acids use H plus ions in water. What happens when bases is dissolved in water? When bases is dissolved in water to give hydroxide ion or OH minus ions. So if a solution has high concentration of H plus ions, so that is acidic. If a solution has high concentration of H plus ions, that is acidic. If a solution has higher concentration of OH minus ions, so then it is basic. If a solution has high concentration of OH minus ions, so it is basic. So bases are soluble in water, so it is called it as alkalis. The reaction with acid or base with water is highly exothermic. The reaction of acid or base with water is highly exothermic. You know that in your previous classes, what do you mean by exothermic reaction? Once again, I am repeating, you recalled it. Here, the reaction in which heat is released, that reaction is called exothermic reaction. The reaction in which heat is released, that reaction is called exothermic reaction. And then, so what happen? So strong acid or how strong acid or base solutions are formed? How strong acids or bases solutions are formed? We know that. So how acid base indicators can be used to distinguish between an acid and base. We have also learned in our previous section about the dilution and decrease in the concentration of H plus or OH minus ions in the solutions. So we can do this by making use of a universal indicator. Here the name of the universal indicator. Yes, here universal indicators means, note down the point, it is very important in your examination. Here question is arise. what is universal indicator? Here, universal indicators means it is a mixture of several indicators. Universal indicator is a mixture of several indicators. The universal indicators shows different colors at different concentration of hydrogen ions in a solution. The universal indicator shows different colors at different concentration of hydrogen ions in a solution. A scale for measuring hydrogen ion concentration in a solution called pH scale has been developed. A scale used to measure hydrogen ions concentration in a solution called pH scale has been developed. Here, the P in pH stands for potence in German. In German, here potence means power. In German, potence means power. On the pH scale, we can measure pH generally from the very acidic and very alkaline. Here, the pH value is 0. It's when it shows 0 to 6. So, this pH is acidic. When pH value is 7, so this pH is neutral. When the pH value is 8 to 14, here the pH value is alkaline or basic. So here, simply to say as the number indicates the acid or basic nature of solution. And higher the hydronium ions concentration and lower the pH value. Here, the pH of neutral solution is 7. Its values is less than 7 on the pH scale, so it can be represent an acidic solution. When pH value is less than 7, so the pH scale represent an acidic solution. As the pH value increases from 7 to 14, so it represented an increase in OH minus ion concentration in the solution. So that is increases in the strength of the alkali. Generally, paper impregnated with the universal indicator is used for measuring the pH. Here, pH paper changes color to indicate the specific pH value. So once again I repeat it. When pH value is less than 6, so it is called it as acidic. When the pH value is 7, so it is called it as neutral. When the pH value is 8 to 14, so it is called it as alkaline or basic. Here pH paper changes color to indicate a specific pH value. So observe the pH paper. So how the colors or changes in the when we put the acid, bases or alkaline in the pH paper. So it can be shows that which one is acidic and which one is base and which one is alkaline. And then the strength of acids and base, it can be shows that acids that gives rise to more hydronium ions or hydrogen ions are said to be strong acids. Acids that gives rise to more hydronium ions or hydrogen ions are said to be strong acids. So bases that gives rise to more hydroxide ions are said to be strong bases. Bases that gives rise to more hydroxide ions are said to be strong bases. And acids that gives rise to less hydronium ions or hydrogen ions are said. And bases that gives rise to lead hydroxide ions are said to be weak bases. Here, acids gives rise to more hydronium ions or H plus ions, or bases that gives rise to more hydroxide ions or OH minus ions. Here acids are said to be strong acids and the bases are said to be strong bases when they gives rise to OH minus ions. Acids gives rise to less hydronium ions or hydrogen ions and bases that gives rise to less hydroxide ions or OH minus ions, so it's said to be weak bases. And then importance of pH in everyday life. Importance of pH in everyday life. So we shall discuss in tomorrow classes. Okay dear students, today we shall discuss about the importance of reaction between acids and bases. And then what happen an acid or base in a water solution. And importance of pH value and then the strength of acids and base. Okay, thank you.